Hello students, how are you? I hope you will be good and enjoying physics at home these days. I am Dr. R.K. Sharma, your physics educator. So we will continue some more questions on the combination of the capacitors, series and parallel, that is the mixed combination. Okay. So this is the topic is very important. Okay. So again we have to basically calculate the equivalent capacitance, okay, between certain two points. So let's take some important question. That's question number 1, right? Let's say this is the point A. There is one capacitor here, one more here. Okay, like this. One capacitor here. Are you getting points? One here, and one here like this. Okay. So we are connecting. Okay? So we are making now a little more tougher questions basically. Fine. So now let us assume, that is, suppose this is how much, the 6 microfarad, 6 microfarad, 6 microfarad, okay, clear? Alright, so then let's say this is the 2 microfarad, alright, so when it is a 2 microfarad, okay, so let's say this is a 4 microfarad, okay, and this also 4 microfarad. So any values may be given to you, right, between A and B. So basically question is we have to understand the logic, how to proceed, how to solve a question of mixed nature. So as I told you, we can start from any one point, okay. So suppose we start from point A. So some charge is flowing here, okay. Alright, the same charge continues. But here at this point we are finding some charge goes this way and some charge this side. So it means these two branches are in parallel. But when you continue in this branch, so you find these 3 capacitors are already in continuation, meaning thereby they are in series. So first of all, you will solve these 3. So if you put it them, let's say this is the C1, it is C2, this is C3, C4, C5, and that is C6. So as I explained you, because from here there is a branch, this and this, okay, but in this branch you find these C2, C3 and C4, they are in continuation. So first of all they are in series. So you may say the C2, C3, C4 in series. So therefore the resultant, maybe let's put it as C dash. So this will become 1 by 6, 1 by 6, 1 by 6. Overall this is 3 by 6, so you will get 1 by 2, meaning thereby C dash is 2 microfarad. Clear? So as I was explaining earlier as well, okay, so whatever is equivalent capacitance of these 3, that is C dash, let us redraw. It will be easy for us, okay, to understand. So if I redraw this, okay, so A was here, then first capacitor as usual, this as usual, this as usual, okay, fine. This is the B. So here it is C1, here it is C6, here is C5 as usual. But now we have a new capacitor, okay, of the 3, that is C dash, and its value has come as 2 microfarad. And this was already 2 microfarad, this is a 4 microfarad, this was also 4 microfarad. Now think, as we were saying, from here, there was a branch, so then these two are in parallel. So that means C5 and C dash are in parallel. So you can find out resultant of them. So let's say their resultant is C double dash. So in parallel, the direct capacitance is C double dash will be equal to C5 plus C dash. That is 2 plus 2, meaning 4 microfarad. So again, redraw it again, So that will be more convenient and easy for us, okay. So this is the resultant, see. So this is C1 as usual, no issue at all, that is 4 microfarad. Now this is basically C double dash, and its value has come now as 4 microfarad, and this is already 4 microfarad. Now what do you think about them? Aisa it seems, these two may be in parallel, but it's not. Because we have to start either from this end or that end, okay. If you start from this end, okay, and you just move. So I told you, if you are moving without lifting our finger or the pen, okay, means there is a continuous series, continuous chain, meaning thereby they all are in series. So finally you may say that is C1, C double dash, and this was basically C6, okay, and C6. all three in parallel. They are in parallel. So in parallel we directly add. So therefore, so net capacitance Cp will be equal to sum of all, that is C1 plus C double dash plus C6. And fortunately all are 4 each, okay. So therefore 4 plus 4 plus 4. So what do you think? They are now in series actually. They are in series. So they are in continuous, they are in series. Correct? So resultant will be 1 upon Cs in series. It was basically 1 upon C1 plus 1 upon C double dash plus 1 upon C6. So alright, we can put it as 1 upon 4 plus 1 upon 4 plus 1 upon 4. So 3 by 4. So ultimately the final result Cs is 4 by 3 microfarad. Clear? So we have moved little complex. So I am just repeating once more for your convenience, okay. So when we start from here, okay, so we come here. Now we found there is a branch, right? So that means initially we have to think that this branch and this one, they will be in parallel. But when we move in this particular branch, okay, we come across the three, that two in continuation. So first of all, these three were in series. So we found out their resultant comes at this, and we redraw this result circuit, okay. So in place of 3, we draw the resultant one. C5 was there and these two. And when we see these two were in parallel, so directly add them, okay, and redraw this. It is in continuation, that is in series. So final result is this. Clear? Alright, so let's proceed further. So today we are going to take very important questions, right? So please be focused. Very important question. Now I am taking this is the CBSE question basically. Alright, what did they see? Plus minus C. So either value we can take it as a metal. Only thing is we should know the method, the procedure. That's important, okay. So let me say here is a 600 volt, okay, is applied here. Clear? And let's say this is the C1 capacitor, this is a C2, this is a C3, and say C4. And if we say the C1 is let's say 100 microfarad, the C2 as well as C3 both are say 200 microfarad, and C4 is say again 100 microfarad. So this is 100, these are 200 each, and this is 100, okay. Question is now, no doubt, let me put it as point A and B, So first of all, there are 3 questions, this very important CBSE examination, right? So the A part, we have to find out the CT, means total capacitance of this combination. The second question will be find the charge on each capacitor, and of course the voltage on each capacitor. Very interesting question. Alright. So let us do the mastery over this. How? If you start from here, right? So what is happening? There is a branch, one this side, other this side. So whenever there is a branch like this, okay, so you will say, sir, this branch and this branch will be in parallel, but when you move this side, so they are in continuation. So first of all, you will say, sir, these two are in series first. So let us put, the C2, C3 in series. So therefore, what is the resultant? 1 upon C2, 3 will be equal to 1 upon C2 plus 1 upon C3, and they are 200 each, okay? So 200 each, fine. So that is 2 by 200, 1 by 200, 100 only, right? 100. So what I mean, that is C23 is coming as 100 microfarad. What was the next step? After that, we generally redraw the diagram, because these two are being replaced by another one. So the new position may be like this. Clear? Just see how I am drawing this. Okay, so it is going to help you a lot. Positive, negative, 600 volt is here. Now this is a new one is C23. This is the C1 and this is the C4. At a glance, the moment you see, it seems all three are in parallel, but they are not. Why? Because we have to put the logic. So the moment you start from here, okay, you find, oh yes, it's getting divided, okay, one this side, other this side, meaning thereby, and they are like this, okay, joining again. So means these two now in parallel first. They are in parallel, okay. So you can say now, that is C1 and C23 in parallel. So let's say the resultant is C123. And parallel is direct addition, C1 and that is C23. So both are 100 each, okay. So 100 become 200 microfarad. So please redraw. And the last time, let's see. So if we redraw, because in place of these two, there is another capacitor, okay. So finally it seems like this, okay. Is it visible? Yes. So now this is becoming now C123 and its capacitance is 200 and here it is a C4 and positive negative 600 volt. Okay, fine. Let's say A and B points. Now again you find, oh sir, they are two in parallel, but no. Why? They seems to be, in parallel, but they are not, because the moment you will start from here, okay, you find they are in continuity. They are in continuity means series. So finally you will say, sir, C123 and C4 are in series. So therefore the resultant capacitance is CT total. Alright, this will be 1 upon C123 plus 1 upon C4. So that is how much it is? C123 is for 200. Okay, this is 100. So 200 LCM, right? It is 1 plus 2, so that is 3 by 200. Fine. So finally you will get the CT is equal to 200 by 3 microfarad. So this is the first answer, okay, of the question. So initially they asked to find the total capacitance of this resultant, of this combination. The next question is, we have to find out the charge on each capacitor as well as the voltage on each capacitor. How to proceed? So I hope till this step is all clear. Very interesting. It has been asked in CBS examination in various forms a number of years. Alright, so we will take the other part, that is the voltage and the charge on each capacitor. Clear? Alright, so let me put it, for our knowledge, this was basically 200 and this is 100, okay, and this was how much? 200 each, okay, so this was 100 and this was 100. These were 200 each. Fine, alright. So see, for the voltage and charge on each. Now see, just now I was saying that is these are in series, right? So naturally when some charge will flow, okay, so this C4, so let me put the charge flowing is Q4, ends in series, charge remains the same, alright, and voltage is 600, and voltage across these will be different because in series we have shared earlier, okay, the voltages are different. So here let's say voltage V4 and here voltage is V123. So you can easily say by voltage law, that is 600 must be equal to, that is V123 plus V4. Voltage equal to, since Q is equal to CV, so V is equal to Q by C, and charge is passing through C4, say Q4, so same charge will flow through this also. So you can write down, that is 600 is equal to, this voltage will be how much? Charge upon capacitance. So charge is, let's say, Q4, and what is capacitance? Capacitance we know, that is 200 microfarad, okay. So micro we have to actually put it, okay, because it's a numerical, right? Plus V4 means this is again Q4 upon its own capacitance, that is 100. So this is the 100 into 10⁻⁶ because it is in microfarad. So don't you think 600 Q4 Q4? So I think it is very easy mathematical calculation to get Q4. So if you will solve it, okay, I hope the Q4 will be equal to 8 into, let me just see how much it will come. Can you try this? Okay, just try for a minute. Okay, so when we simplify this, okay, this will come as 4 into 10 to the power minus 8 coulomb. Got it? And once a charge is known, how to find the voltage? So therefore you can simply say, right, that is C we know already. So V is equal to how much? Qy, that is Q4y, C4, that is V4 we want to find out, okay. So Q4 we just got, okay, that is 4 into 10 to the minus 8, and C4 was 100 into 10 to the minus how much? 6, okay. So you will get it as 400 volts. So very interesting that the V4 we are getting as 400 volts. Please be focused because question is very important, was asked in CBSE examination, right? Okay, so a set of answer we got, okay, that is the charge and voltage on the fourth capacitor will be this. Charge is this and voltage is this. Clear? Now very simple, because they have asked, we have to find out the charge and voltage on each capacitor. So this is only one capacitor, okay, that is the fourth one. So if the C4 is having, the voltage 400 and total was 600. So because in series division is there, okay, so here is a 400. So how much will be the voltage on this? Simply 200. So we can simply say like this, see, that is the V4 plus V123 must be equal to 600. So we need to find out V123, okay. So 600 minus V4, this V4 we got, 400. So finally you are getting at 200 volts. Clear? So this V123 is actually the voltage on this, which is the resultant of these two in parallel, and parallel mein voltage mean the same, meaning thereby the voltage on this will also be 200 and voltage on this will also be 200. Please understand, very very important to understand. So V123, right, is voltage on what? On the parallel combination of this, okay, that is will be on C1 as well as on C23, meaning thereby V1 will also be 200 volts. Clear? And of course V23 will also be 200 volts because they are in parallel, and parallel the voltage remains the same. And when you know the V1, C1 you know, alright, so you can find out charge as well. So therefore you can find out, so Q1 will be equal to C1 V1. So C1 is there, okay, that is 100, okay, 100 microfarad, that 10 to the minus 6, and this is the 200, okay. So how much charge you will get? Okay, you will get 2 into 10 to the power minus 8 coulomb. So this way you got the another answer, that is the voltage on the first capacitor C1 and the charge on the first capacitor Q1 are also known to us. Clear? Now what is left? After this we are left with these two, and fortunately their capacitances are same and they are in series, right? So being equal, okay, so what will happen? Voltage will divide. So the total 200 volt will divide 100 each. Clear? So let's do like this, because we have now the C2 as well as C3, right? The total voltage across this was 200, okay, but they being in series it will equally divide because the capacitance is the same, okay. So therefore we can say the V2 will be equal to V3 is equal to how much? We'll divide 200 by 2, that is 100 volt each. Once you know the voltage and capacitance are already known, so you can find out the Q2 as well. So Q2 will be equal to C2 V2. C2 is how much? 200 into 10 to the minus 6, and V2 you got 100, so you will get again 2 into 10 to the minus 8 coulomb. And similarly you may get Q3 as well, okay, that is C3 V3. V3 is also nothing but 100, so that is 200 into 10 to the minus 6 into 100, so again 2 into 10 to the minus 8 coulomb. So this way we got all the answers, okay. There were actually 3-4 questions. This, what was the resultant of this? I think we calculated between A and B. The net capacitance we got, you know, was 200 by 3 microfarad. Then the second question was to find the voltage and charge on each. So fourth we got earlier, okay, I think it was 400, and you know the charge was also there, okay, and C1 we got here, okay, that is voltage V1 and the Q1 as well, and of course Q2, Q3 and V2, V3 got here. So this way we can answer it, okay, the most important question of CBSE. Clear? Understood? Yes. So this way, you know, we have to solve. Now I will take, you know, one very most important question. It was asked in even IIT JEE as well, right? And is now being asked in CBSE also. Okay. So how we'll proceed? So I'm rubbing this. So next question is again most important question, okay, and was asked earlier in IIT JEE and now is being asked in CBSE as well. And you will enjoy this. I hope you are enjoying understanding all concepts of physics. I am trying to make physics very easy for you. So question is, I am going to draw a network. The total capacitance or resultant capacitance is already given, say 1 microfarad, and one of the capacitor, okay, will be unknown. Let's say a small c, right, is not known. So there is a one, you know, the diagram is there. There is a, you know, one combination of capacitors there, okay. Total capacitance between A and B point is this. One of them is unknown. We have to find out this unknown value. And what is the circuit? See, let me put this C. The first capacitor itself is unknown, right? So let's say this is the first capacitor, okay. So this is the mixed combination, very important. It was asked in IIT JEE. All right. So please be focused. Try to understand this. B. Clear? So here the question given is between A and B, the net capacitance is given. Okay, that is CAB is equal to 1 microfarad. And this is unknown, C1, right? So let's say this is a 2, this is also 2 microfarad, okay? All are in microfarads, right? Let's say this is a 4 microfarad, okay? Clear? And say this is a 4 microfarad, let's say again 4 microfarad, okay? And this is a 2 microfarad, and let's say this is a 4 microfarad. I'm just assuming, any value you can take, okay, is a material. And this C is unknown. So this is unknown and all are given like 2, 4, 2, 4, 2, 4 like this. And the total capacitance between A and B is already given to us, 1 microfarad. We need to find out the value of this. How to proceed? Very interesting, easy to solve. See how? Again I tell you, let us stick with one important fundamental. If we move in continuation, whether we are turning here and there and all, okay, material, okay, but continuity is there, okay, means series. As and when we are moving and there is a branch like this, okay, so that means parallel, right? Start from here. So here if we start, okay, so now here there is a one branch, there is other branch here. So first of all, let me say these two branches will be in parallel, right? Right, they themselves are in parallel. But now take, you know, one branch itself. So when you move in this branch, this one, and again there is a branch. So first of all we find when I move in this branch, I found these two are divided. meaning thereby these two capacitors are in parallel. And once they are in parallel, I think by this time you know very well, okay, you can easily answer it orally. By the way, these two capacitors are equal to 2 each and they are in parallel. In parallel it is combined. So can I write directly? So it becomes 4 microfarad, nothing else. The combination of the two in parallel. Clear? So let us leave as it is as of now. Now move in this branch. Okay, we are going. Here we find this and this. There is again branch. But here when I move in this branch, I found these two are in continuity. So meaning thereby these two are in series. And in series 1/4. So what I feel, this will come as 2. Clear? It will come as 2 microfarad, half of them, half of this value, okay? Because 1/4, 2/4, that is 2, being in series. So I think, and this 2, okay, so let me redraw it, okay, otherwise you will get confused. So the new formation will be like this. A, so C is unknown, alright, not as you. Here is the 4, yes, correct. Now in place of this there is a new capacitor, okay, that is called 4 value, okay. And now this, here is 4, no issue at all. Now, yes, these two are getting 2 now, okay, 2 microfarad, correct? No, yes, this is here now. It goes this way, these two are now this only, and here this, okay, like this. So this is basically the final combination. So in place of these two we got 4, 4, 2. So it's a 2 microfarad, is already 2, is 4, and this. As I was saying, that is these two are in parallel, like this, branching is there, okay. So what do you say, sir? This is, these two are in parallel, and that too they are same, get added 4. Alright, so let me redraw it again, for you, for more simplicity. So this is C is there, no issue at all, okay. So I will put it as 4, this is also 4, and I move to B, and here is a 4, fine. And here this is also becoming 2, 4. Alright, and now I reach at this point B. Here is a 4, here is 4. When you move after this, okay, this point, you move this way, these two are in continuity. So what do you say, sir? Series. Yes, so series it become 2 actually. And when you move this side, okay, these two are also in continuation, so become series, that 2. So let us redraw it finally. Yes. So the final position will be like this. See this unknown here. Yes, one capacitor is here, okay, which is becoming now 2. And this side there is a, this whole is becoming 2. Yes, that is 2. And finally we are reaching at B. What do you think? So it's very easy. Because after this, these two branches are there like this, reaching at the same point, okay, meaning thereby these two are in parallel. So they being in parallel, okay, become 4, direct addition. So new resultant will become C. This C is basically the unknown, and the resultant of these two is becoming 4, and you are reaching at a B point. As I told you, when you move from A to B, this. Though we are turning like this, okay, it doesn't matter, you turn this, but if you are moving in continuation without lifting or branching, means these two are in, or those number of capacitors will be in series. And resultant of these two is given to us as 1 microfarad. So therefore you can say the resultant, that is a CT, okay, must be equal to, they are in series, so that is 1/C plus 1/4. We need to find out this, because this is already known as 1 microfarad. We will convert micro into farad later, and 1/C plus 1/4. So therefore 1/C is equal to 1 minus 1/4, because this 1 only, minus 4, so this become 3/4. So what is C? C is 4/3 microfarad. Correct? So this is a most important question, as I told you, asked in CBSE as well as competitive exam. Most important question it was. Okay. So this way we can solve. Okay. So once you know this, this was quite mixed, parallel series and all that. Okay. So all right. So I think I would like to take one more last very interesting question, okay, so that you become more and more confident, okay. So there is no fear at all, okay, to solve any question based on combination of capacitors. The last question we will take, though there are many more, right? There's no end of good questions. So I will take a little more complex this time, let's see, but we will do a little faster. See, the resultant is something like this. So let me put it at AB. It's very complex. Even we can take up to infinity as well. Fine. So many more loops we can take. It's immaterial, okay. So but let us take up to this only, right? So let me put it like this. Suppose this is the all are 8 microfarad, okay. Say the 8. Let me write. It's very convenient for us. 8 microfarad, 8 microfarad, 8 microfarad. Like this. 8 micro, 8 micro, 8 micro. Fine. Let's say this is the 4 microfarad, this is the 4 microfarad, okay, the 4 microfarad. Let me see, I will change the value if just for our convenience, okay, because I just wanted to share the basic fundamentals, okay, about this. Clear? Very easy. Now we will be faster, okay, and very conceptual question it is. We once have understood the series parallel, okay, how the charge divides or the voltage divides, okay, it will be very easy for us, okay, to solve it. Now see, start from here. So ultimately the question is again we have to find out the resultant between A and B, okay. So you can put it like this, okay, maybe this D, E, F, G, H, J, etc. all these points, okay. But let me start directly. See, if we start from here, so let's go like this, we are moving it. Ultimately we have to just compress it between A and B points. So the moment you reach over here, okay, what you see at F point, just think about F and H. So you see at this one branch, whatever charge comes, okay, please understand, important, whatever charge comes here, okay, it will divide here and here. That means these two are in parallel. But let us think, when we are coming this, so they are in continuation. So I will do it directly, please. These two are in series, become 4. And this 4 is directly in parallel because we are talking about F and H as of now. So this 4 with this 4 is in parallel, become 8. Okay. So can I put it at 8 here, okay? If I combined, this 4 with this 4. Right, so I will redraw it, okay. So many redraw are to be done. So later on I will just take a little faster because this is the basically concept. 1, 2, this, okay, 1 here, all right, and this, yes, and this, fine, here, and I am reaching here, yes. So this these two were in series 4 and this 4 with this 4 was in parallel, become 8. So meaning thereby this is actually becoming 8, okay, and here that means this is my point F and this is H. Yeah, this is E, D like this. Got it? This is the 4, 4, 4 like this, and these were 8, 8. Alright, and this is 8. So what do you think again? See, very interesting. It's clear to you. Once again I am emphasizing on this. This 2 being in series become 8, or 8 means half of this 4, and this 4 with this 4 original were in parallel, so become 8. So that 8 I have put it here. Now when talk about between E and H, so from here this is the 8 and 8 in series, right? So become 4. So please remember this is becoming 4. And that 4 with this 4, because from here this is one branch, this is another branch, so these two are in parallel, okay. So this 4 and this 4 will become 8. I can do it in one step itself, okay. 4 and 4 becoming parallel means 8, and this 8 with this 8 is in series, become 4, and this 4 with this 4 in parallel 8, and this 8 with this 8 is again series, that is 4, and this 4 with this 4 is again 8, right? And this 8 and this 8 is becoming 4, clear? And that 4 with this 4 is again 8. So finally what I can do is the A, so this is basically the 8 and I am at D point, and this is 4 actually, that is B point, okay? And here, you know, all this I comprise it as, you know, the 4 like this. So this is basically becoming 8, okay? So finally the position will become like this, okay? Whatever you say, this one. Because these 4 are in parallel, so becoming 8. And this is also 8. And these 8 are in series. So what is the answer? The answer is 1 by 8, 1 by 8, that is 4 microfarad. Clear? So this way we can solve. I think please try, you know, it's very simple. I am just compressing slowly and gradually. Got it? So this 8 becoming 4, that 4 with this 4 become parallel, okay, that's 8, and this 8 with this again 4, and that 4, this 4 with the, you know, parallel 8, and this 8 with this 8 in series 4, this 4 with this 4, 8 parallel, and this 8 and 8 series, that's 4, and that 4 with this 4 is again 8, and so this 8 and this 8, answer is 4 microfarad. So this way we have taken a number of questions, okay? So I am sure that is all the concepts of the series, parallel and mixed combination of the capacitors is very well understood by you, okay? I hope you enjoyed this class on the capacitor combinations, okay? So do a lot of revision and writing please, okay? To be more confident, okay? And more happy and cheerful, fine? Thank you, have a nice day.